This is the first video in section 3. This is about how energy is supplied to us. Where does the electricity we use come from? What is the future of our supply of electricity? So we have to start from where most of our electricity comes from at the moment, which is from power stations which burn either coal, which is the example in this video, or anything that I say really is pretty much the same for gas. Gas power stations have taken over in the last few years, so there are a lot more of our electricity now comes from gas for reasons that we'll look at later. But from the point of view of this video, all the information really is the same. So we're going to look at the main parts of a power station. We're going to look at a bit of a reminder from energy, then talk about the energy changes that they make. We're going to talk about efficiency and Sankey diagrams, which is a reminder from the work from Unit 1 at the start of core physics. So just to relate this to the real world, here's an aerial picture of a real power station. A huge area of land used. Here's some labels on different things. So we start from 1 here. You'll be able to see down here the rail link. This is where usually power stations, unless they're on the coast at least, get their coal from railway trains. So the railway trucks come in here, dump the coal. Power stations always keep a good stock of coal. There's political, historical reasons for that, but obviously practically, just to make sure you're always going to have enough coal, there's a huge area put aside to keep the coal. Once you've got the coal stock, you see this huge machine here is designed to take the coal out of there and put it onto part 3 here, the conveyors. Okay, none of that's particularly important, but just so you get the idea. Obviously, if this was a gas power station, we just have a gas pipeline coming in. Now we get to the crucial bit. So in 4, this is where the boilers are. So they're burned in here. So this chimney here, this is smoke coming from the chimney. A very small amount of actual smoke is released by the chimney from burning the coal. Most of the ash that's left is trapped in ways we'll look at later on. But this is the boilers. This is where the water is turned into steam. The steam is sent around there. So after it's been used, it goes to number 5 here, the cooling towers. Okay, this steam here is water, not the same water in this system, but water that's taken usually from a nearby river. This is why coal-fired power stations are always built next to rivers. This is water that's come out of the river rather than the cleaner water which is going around these systems. So the hot steam goes into the turbines. So number 6 here is the turbines which spin round to drive the generators. Once you've made the electricity, you need to send it off around the country, so there are transformers. Okay, so this part of the power station here is the transformers, and once you've transformed the electricity in ways that we'll talk about when we do the national grid, then here you might just be able to pick out and hear the pylons which are carrying the wires to the national grid off around the countryside. Okay, here's an animation which will make that a little bit clearer hopefully than the real picture. So we start off with the boiler. Okay, the boilers have the water that comes into them. First thing you've got to do is burn something, whether that's the coal or the gas. You burn something, that will turn the water into steam. The steam drives the turbines round. Here's the turbines. One of the common mistakes here is that the turbines just do what they tell you. They turn. They're not actually making any electricity. Okay, once the turbines are turning, they spin the generator. The generator is the bit that generates the electricity. That's what it's called, a generator, okay? No transformers here, okay, but we will talk about soon how the electricity has to be transformed up to a higher voltage to go around the national grid, and then you can have a cup of tea. Okay, just the cooling towers are there to turn that steam back into water because you need a difference in pressure between these two sides to actually enable the turbines to spin round. So those are the basic parts of the power station. If you understand that, then the rest really is a revision of Unit 1, where we talked about types of energy, efficiency, and Sankey diagrams. Okay, so here's the energy transforms that are going on. So we start off with the boiler. In the boiler, you're burning the fuel, so that's chemical energy in the fuel. That's turned into heat or thermal energy in the steam. They drive the turbines, so think ahead, what energy are the turbines going to have? Well, the turbines are spinning round, so that's kinetic energy in the turbines. The turbines drive the generator, so the generator's job is to turn that kinetic energy into, finally, electrical energy in the wires. Okay, you'll notice there's no energy change going on. This is just a transfer of the energy from this kinetic energy in the turbines to kinetic energy in the generator. Okay, the next step we could do is to remind ourselves about efficiency. So remember, efficiency is the useful energy out divided by the total energy in. Okay, the key point, remember about this, is that all of the energy that you put in comes out. The question is how much comes out as what you want. So here are our steps. We've got chemical energy in the fuel, we've got heat energy in the steam, kinetic energy in the turbines, then the generators, and then electrical energy in the wires. And we can talk about the efficiency of these different parts, and then we can talk about the overall efficiency of the power station. So the coal, the energy of the coal turning into the heat energy of the steam, we've put 3,200 megajoules in, we've got 2,800 megajoules out is what we want. So we do 2,800 out of 3,200, 87.5%. Okay, you can work your way through those. So here's the 1,600 came from 2,800. 1,400 from 1,600, 1,000 from 1,400. There's the percentages. Think about this. If you were an engineer in the power station, you might want to look at these numbers to see where the problem is. So clearly the biggest problem in this one is getting the thermal energy from the steam into the turbine. If you could improve that process, that would make a big difference to the overall efficiency. Okay, to get the overall efficiency, look at what we've done. We've taken 3,200 megajoules of chemical energy in the coal, and we've turned it into only 1,000 megajoules of electrical energy in the wires. Okay, so overall the efficiency of the power station is somewhere around 30%. That's a fairly realistic figure for a coal-fired power station overall. Okay, the other thing we can do is represent this in a Sankey diagram. So remember the point of a Sankey diagram, we start here with our energy in the coal, we draw a line here which is to some sort of scale as to how much energy that is. And then what happens is some of this energy is wasted as thermal energy. So you remember we said we had 400 megajoules wasted. Notice the crucial thing is the width of this arrow to scale shows us the 400. It's an eighth of the width of this arrow. Okay, also over here what's carried on has got narrower because this is only 2,800 megajoules now. Okay, then we do the next stage. We waste a lot of thermal energy in the turbines. So the line gets a lot narrower, then we waste some energy from the generator, then we waste a bit more thermal energy from the wires, and there's our useful energy. So there's a Sankey diagram representing the whole energy transfer of the power station.